Welcome. This is Raina Fitzgerald, and in this lesson, we're going to be working with rational expressions. Here, we're going to look at complex fractions. A complex fraction is a fraction that has another fraction in either the numerator or the denominator. When working with complex fractions, what we can do is I can re-express this as 2/3 over or divided by 1/2. And we know that division is multiplication by the reciprocal, so this becomes 2/3 times the reciprocal of 1/2, which is 2/1. And now I can multiply. 2 times 2 is 4, and 3 times 1 is 3. So the answer to this problem is 4/3. Here we have another example. This time we have a fraction only in the denominator, which still makes it a complex fraction. 5 is 5/1, and we are dividing this by 1/4. This is the same as taking our 5, or 5/1, and multiplying it by the reciprocal of 1/4, which is 4/1. 5 times 4 is 20. 1 times 1 is 1, and our answer is 20. Here is another example of a complex fraction. In the numerator there's a fraction, and in the denominator there is a fraction. So let's move this to the left. And we're going to work left to right and then down. The first thing we want to do is take our 5, which is 5/1, and we want to have a common denominator. That common denominator will be x. So we're going to multiply 5 by x over x, which is essentially 1, so we're not changing the value of 5. And then, of course, we have 1 over x. And let's just work only with the numerator first. So this is equal to 5x over x plus 1 over x. And now I can combine, let me move this over a little bit, I can combine my two fractions. They have a common denominator. So I end up with 5x plus 1 over x. That's my numerator. Now let's take a look at the denominator. Here in the denominator I have x plus 1 over x. Well, x is essentially x over 1. And so they don't have a common denominator. We have a 1 and an x. So to have a common denominator, we are going to take the x over 1, and we're going to multiply the top and the bottom by x. So we're multiplying it by x over x, which is essentially equal to 1, so we don't change its value, plus the 1 over x. And we end up with x squared over x plus 1 over x, which gives us x squared plus 1 all over x. So what's going on here? Well, I took the numerator and I combined the numerator into one fraction, and then I took the denominator and I added it together to get another fraction. So now again we have a fraction divided by a fraction. Let's write that out. So we end up with, it's coming down here, and let's actually move this up. We can move this up, give ourselves some more working room. Okay, and move this up. Good. Okay, so we end up with 5x plus 1 over x, and that's divided by x squared plus 1 over x. And if you want, you can put parentheses around these binomials. And remember that division is multiplication by reciprocals. So this is 5x plus 1 all over x. And instead of dividing, we're going to multiply by the reciprocal, which puts an x on top and an x squared down on the bottom. That's our reciprocal or multiplicative inverse. And when we multiply this right across, we end up with 5x plus 1 multiplied by x over x times x squared plus 1. And I hope you can see that these are all facts, so we can cancel out these x's. And our final answer is in the numerator, 5x plus 1. And in the denominator, we have x squared plus 1. At this point, you might want to see if they could be factored further, but they cannot. 5x plus 1 is a linear binomial. It's fully factored. X squared plus 1 is a quadratic binomial, but it cannot be factored. It is the sum of two perfect squares, not the difference, so there's no way to factor that. It's prime. This is our final answer. 5x plus 1 over x squared plus 1.